Okay, we see we can provide so many mechanisms to keep the reliable service from the TCP. The first one is establish the connection before we transmit the packets. So this way we call it three-way handshake to establish the connection. For example, now here we have the PC1 and the server. And now if the PC1 wants to send message to the server, I will send the TCP packets to the server, and these packets we call it SYN packets. And about these packets, we have the sequence number. For example, we use the A to indicate the sequence and number. And this message you can see like the function of the hello, hi, I want to send message to you, do you exist? Something like this. And when the server receives a message from PC1, I will give a reply. And about this reply, we have two functions. The first one, we have to tell with the PC1 I exist. And the second function is I also have to give the acknowledgement I receive the hello message from you. So how to meet the requirement of two functions? The server will send out the packets, and this packet, the sequence number is B. And A and B, maybe the number is same, maybe it's different. They don't have any relationship. But the ACK number, this one has a special meaning. The number will become A add 1. And this A add 1 means tell the PC1, I already received the message from you, the sequence number is A. So this is two-way to the handshake. And about the PC1, I receive the message from the server. I also have to give the reply. And about this reply, the sequence number will become A to 1. That's because I already sent the message of the sequence A to the server, and the server receives successfully. And I will give the next message, and the sequence number is A to 1. And the ACK number will become B to 1. The B to 1 means I will give the acknowledgement of the server. I already received the message, the sequence number is B successfully. So this is the first step to establish three-way handshake to establish the connection. So this is the first one. After we establish the connection, we want to transmit the message, right? And when we transmission the message, we have two mechanisms. One we call is acknowledgement, and another one we call is window. So what means acknowledgement? During the data transmission, the sender will send the date of the size of the window, and the receiver only confirms it once is enough. And the second one, if the receiver's response capacity is insufficient, the window size will be adjusted, and the receiver will send the data according to the new window. So these are two principles when we transmit the message between the sender and the receiver. I also will send an example for you. For example, also the PC1 and the server. Now we establish the connection, right? And then the TCP, the PC1 will send out three segments, and each segment will have the sequence number A add 1, A add 2, and the Windows number is 3. 3 means I will send out the three segments at the same time. And when the server receives this message, first we will give a reply, right? I already received all the message you sent to me. This is the first one we have to send. The second one, I also have to check the compatibility from my side. If the compatibility is not matched, I also will give a reply. Please maybe reduce the window size. That means next time maybe you can send less message, and I will deal with the message, and then you can continue send the message to me. So how to meet the requirement of the server? I will give the acknowledgement. The acknowledgement number is A add 3, and the Windows number is 2. So, about the PC1 receives this message from the server, the next part I will give a reply. And I only send 2 segments to you. The first sequence number is 823 and the second is 824. But now the windows will to become 2 and I only send 2 segments to server. Okay, so this is the transmission mechanism of the acknowledgement and the window. And about the server also will give a reply. The AC key number will become 8 to 5 and the window to become 2. If my resources enough, I maybe will change the window to become 3. And in this process, maybe some message in the network is missing. For example, when a packet fails to transmit due to the network problem, right? Maybe your cable is down, so some message will be discarded. And the receiver only acknowledges the previous packet. So let's see the detailed process. For example, PC1 sends 3 segments to the server, right? And each segment we have the sequence number A821, A22. And in this process, maybe the third segment is missing. So, how to find this problem? About the server, I only receive 2 segments. So when I send the message to you, the AC key number will become A22, A add 2. Because if I receive 3 segments, the AC key number should become A add 3, right? Now I give you the number is A add 2. That means I only receive the message, the sequence number is A and A plus 1. And the Windows number still to become 3. That means I don't change the window size. I have enough resources to deal with the message. So when PC1 receives this acknowledgement from the server, the next part I send the message to you, I will begin the sequence number to become A22. And because the window is 3, so I will continue send the message of A plus 3 and A plus 4. So this is the process. And if I receive these 3 segments successfully, I will give the acknowledgement of A at 5 and the window size still 3. So this is the mechanism of retransmission. If I only receive some segment from the sender and someone may be lost, or maybe someone with maybe it's wrong, I will use the AC key number to let the sender to give us a new message again. So this is a process. And later, maybe we finish to transmit the message from sender and the receiver. We have to say hello, say goodbye with each other. And about the ending, we also have to keep the reliable ending. So this way we call it 4-way handshake. After the data transmission, 4-way handshake to delete the connection. Let's see the process, PC1 and the server. And the PC1 will send the message out, and this we call it FIN packet, and the sequence number is A. Also, maybe this A maybe is different with the A we establish the connection. It doesn't matter. Okay, this only is a character we indicate the sequence number. And when the server receives this FIN packet, and the FIN packet you can see this is a goodbye. PC1 will send the message to server. I already received everything from you. Now I want to say goodbye to you. And about the TCP, every message I receive, I will give the acknowledgement to you. So the server will send out the AC key. The AC key number will become 821. That means the direction from PC1 to server is broken. Okay, is delete successfully, but we have to delete bi-directional between PC1 and the server. So the server later also will send out the FIN packets, the sequence number to become B. Okay, now I also want to say goodbye to you, to PC1. And the PC1 will give a reply. In this reply, the ACQ number is B at 1. So this is the 4-way handshake. So we will use this mechanism to provide the reliable service before transmission, in the transmission, and after the transmission. And compare with the TCP, the UDP is very easy. And the function of UDP is provide the service as soon as possible. So about the UDP, the name is User Datagram Protocol. And about the encapsulation, also will receive the message from application layer, and later we will add the UDP header and to become UDP segment, and then we will add the IP header. And after that, this message we also call IP packets. But about the UDP header, the message is less than the TCP. We only have 1, 2, 3 lines, right? Source and destination port also should be used on the UDP to indicate different application layer service. And we also have the checksum part. That means when the UDP receives a message, I also will check. Some message may be changed by others or not. That means some bit is be changed or not. I have to do the check. But if I found the bit is be changed by others, I will not use the UDP to let the sender give us a new message again. No, I only will send the result to the up layer protocol. For example, I will tell some TFTP server, I tell you this bit already be changed by others. Please make a decision to let the sender give us a new one or not. UDP will not directly ask the sender to give us a new message. So this is the function of the checksum. So compare with TCP and UDP, the service type is different. The TCP can provide the connection-oriented service, but UDP only provides the connectionless service. So TCP needs so many mechanisms to provide the connection-oriented service, like maintain the connection status, right? Before transmission, we have to establish the connection. After transmission, we have to delete. And in the transmission, we have to use some sequence number acknowledgement mechanism to keep the data transmission reliability. And we also use a window mechanism to finish the flow control. So this is the mechanism of the TCP. But about UDP, it's nothing. But the encapsulation of application layer data, this is the basic function of the transport layer. So TCP have and UDP also have. So this is a comparison between the TCP and the UDP. So last part, here also is a question. In the establishment of the TCP connection, what should be the Y value in the SYN? PC and server. The PC will send the SYN message and give the sequence number to become P, and the server will give a reply, and the PC will give the established message again. So this is a three-way handshake, right? So in this process, what should be the Y value? Please choose the correct answer, and I will explain the detail in the next video. Thank you.
Hello guys, now I think you already see the training video, right? Let's have a brief summary for you. TCP and UDP use a port number to indicate the application and the service. About the TCP protocol, it is a reliable protocol. Before forwarding the packets, we will establish the connection by using the 3 packets handshake. In the process, we also have many mechanisms like acknowledgement, sequence number, something like this. And we also can use a window to control the traffic. About the UDP, it uses less usage. That means if you want to follow the traffic as soon as possible, you can choose UDP protocol. Thank you.